Assalamualaikum and salam sejahtera. Today lecture will be on voltage multiplier. So as you can see, the first one is the function of voltage multiplier, where voltage multiplier use clamping action to increase peak rectified voltage without the necessity of increasing the transformer's voltage rating. A voltage doubler is similar to the peak-to-peak detector but uses rectifier diodes instead of small signal diodes. The types of voltage multiplier can be divided into four categories. The first one is the voltage doubler, where it multiplies the input peak by factors of 2. Second one is voltage tripler, where it multiplies the input peak by factors of 3. And number 3 is voltage quadrupler, where it multiplies the input peak by factor of 4. So there are 3 types of voltage multiplier involved. The application of voltage multiplier is in high voltage, low current, high frequencies. For example, in cathode ray tubes and also particle accelerators. Now we go on to the analysis of the first category, which is half wave voltage doubler. Look at the circuit here. As you can see, if you want to analyze the circuit, you can start with the negative half cycle. Okay, in the notes that has been given, D2 should be D1 and D1 should be D2. So this is an error. So I need you guys to make a correction due to this error. So the analysis involved during the negative half cycle is that D1 will be on and D2 will be off due to reverse bias. So by looking at the purple arrow here, the equation involved during negative half cycle is now it depends on your polarity. If you choose the method to be the polarity to be at the first of the terminal, so the equation will be minus Vp plus Vd and plus Vc1. Okay, I repeat, if you choose the first polarity to be in your equation, so the equation will be minus Vp plus Vd and plus Vc1. So during this cycle, C1 will charge up quickly to the peak value of input. So the value of Vc1 is actually the same as Vp if this diode is ideal diode. Okay, so if it is an ideal diode, this circuit will be short circuit. Alright, so Vc1 will be equal to Vp minus Vd, or it is approximately to Vp. Okay, so you can move V in on this side, so it will be equal to Vc1 plus Vd. Sorry, this is also an error. It is actually equal to sorry, VC1 will be equal to VP minus VD. Yes. Okay. Alright. So we go on to the next slide. So here, as you can see here, this is during the positive half cycle. So during the positive half cycle, the equation will be referring to the purple arrow, where starting from minus VP and then minus VC1 and then go to plus VD and plus VC2 equals to 0. Alright, so during this cycle, your V out will be the voltage at the terminal VC2, where terminal VC2 will be equal to or approximately to 2 VP if diode VD2 is an ideal diode. Okay, so this is the equation involved. V out equals to VC2 and VC2 is equal to VP plus VC1 minus VD. Alright, so here you will get VC1, since VC1 during the negative half cycle is equal to VP. So by substituting the value into VC1 here, you will get equal to 2 VP. Alright, now we go on to the full wave voltage doubler. Okay, this is the circuit for full wave voltage doubler. Okay, during the analysis is during positive half cycle. As you can see here, during positive half cycle, the polarity of VP, this is the plus sign and this is the minus sign, so the current will flow in this direction. So by looking at the red arrow, the current will start here and move towards D1. So D1 will be forward bias, but the current for that flow through D2 will not flow through D2 because D2 will be reverse bias. So if D2 will be reverse bias, so this is actually off, or you can say it is an open circuit. So your circuit will be in this loop only. So the equation during this cycle, you will get minus VP plus VD1 and then plus VC1 equals to 0. Okay, so here VC1 will be equal to VP minus VD, or it is approximately to VP. Okay, so this is the positive half cycle for full wave voltage doubler. Now we look at the negative half cycle. So for the negative half cycle, D2 will be on while D1 will be off. Okay, look at the polarity for the input terminal here. When the current flow in this direction, so you can see that D1 will be reverse bias and D2 will be forward bias. So in this case, this diode D1 will be off or open circuit. So the loop equation will be on this area. That is by referring to the red arrow here.